Welcome back to the channel. So today in this video we are going to understand some more types of sets. The first among them is a finite set. So what is a finite set? A set which contains a definite number of elements is called a finite set. So if I have a set, suppose I have a set and the set contains some countable number of elements. So we'll classify that type of set as finite set. Empty set which has zero elements or no element in it will also be considered as a finite set. So what are the examples? The set of all colors in the rainbow. I have only 7 colors in the rainbow, so this set forms a finite set. I have another example, a set n. Here we are having the set of all x such that x belongs to natural numbers and x is less than 7. So if we enlist the elements of this set, we'll be having 1, 2, 3, 4, 5 and 6. So here again we are having countable number of elements. So this set n will also form a finite set. Another set p where the elements are 2, 3, 5 up to 97. Again we are having some definite number of elements. So this set will also be considered as an example of a finite set. Infinite sets. The set whose elements cannot be listed, that is, set containing never-ending elements, is called an infinite set. Suppose I have a set and it contains uncountable number of elements, never-ending elements. This set will be considered as an infinite set. For example, the set of all points in a plane. A plane consists of infinite number of points. So this set will form an infinite set. Similarly, set of all prime numbers which are infinite again forms an infinite set. Another example, set A, where we are having the set of all x such that x belongs to natural numbers and x is greater than 1. So we know there are infinite natural numbers which are greater than 1. So this again is an example of an infinite set. Another example, set B, where we are having the set of all x such that x belongs to W. Here W represents whole numbers and x is equal to n. Here we can plug in infinite values of n and we can obtain the corresponding infinite values of x. So set B is another example of an infinite set. Note that all infinite sets cannot be expressed in Rooster form because only those sets can be expressed in Rooster form which have some countable number of elements, and infinite sets, as we know, have never-ending elements in them, so they cannot be expressed in Rooster form. Subset. If every element of a set A is also an element of set B, we say that set A is a subset of set B. So suppose we are having two sets, set A and set B, and every element of set A is also an element of set B. So we say that set A is a subset of set B, and we write set A is a subset of set B. In order to understand this concept, take for example, we have a set A whose elements are 1, 2, 3, 4, 5 and 6. We have another set, set B, whose elements are 1, 2, 3 and 4. Here it can be observed that each and every element of set B is also an element of set A. So we can say that set B is a subset of set A. Moving further, we have equal sets. Two sets A and B are called equal if they have equal numbers and similar types of elements. Consider two sets A and B. Here we are having equal number of elements. The elements of both the sets are equal in number and the elements are similar in nature as well. So here we'll be having A is a subset of B and B is a subset of A as well. So in this case, A will be equal to B. So in order to understand equal sets, let us take a simple example. Here we are having a set A whose elements are 1, 3, 4, 5 and 6. And we are having another set, set B, whose elements are 4, 1, 5, 6 and 3. Here we can see that each and every element of A is an element of B and vice versa. So this means that both sets, that is set A and B, are equal. A point to be noted here is that in case of sets, the order doesn't matter. The order of writing elements doesn't matter. For example, if we are writing elements of some set, say A, as 1, 2, 3, 4, 5, we can write these elements in this way as well. 1, 3, 5, 4, 2. So this means that these two sets are one the same. Another point to be noted is that we ignore repetition of elements. Suppose we are having a set A, the elements of which are 1, 2, 2 and 3. This will be considered incorrect because we are repeating an element here. In case of sets, it is necessary to remember that we don't repeat elements. So the correct way to represent the set will be 1, 2 and 3. I hope this makes sense. Do subscribe the channel and thanks for watching.